last time we installed the Rust environment, the compiler, the package manager, cargo, and the IDE. And now we're going to take a look at the structure of a Raster program. So Rust, you have files. The main entry point is going to be main.rs. You can change that, but by default it's main.rs. All the Rust files are extension.rs. Obviously, you can have more than one, but for the beginning, we're gonna put everything in the same file and not care too much about how we can structure the code better. So everything in the same file, and most of the stuff are functions. So the main entry point is called main, and it's a function that would call other functions, and that's it. Well, you have a fairly basic structure. Inside functions, you can have variables, and variables are typed. So everything is typed in Rust. Everything has one type, which is inferred or declared at compile time, and the type cannot change. So here, this variable a is of type i32 because it's set to 10, and in this case, the type is inferred because of the assignment to 10, and 10 is a literal value of type i32. So what types do we have? Now let's talk about primitive types. Primitive types, we have mostly numeric types and some other types like character and Boolean. So let's begin with the easy one. Boolean is a type that has only two values, either true or false, and they represent the value of logical statements. Now, then you have character, which is like this stuff. H is a character. The type of this thing here is a string of character. So it's not a primitive type because you have more than one value inside. Each value is of type character. So we have char, and we have string. String, we're going to talk about that later. It's not as easy as other languages. So we keep that for later. Now, the other types that we have are integers and floating points as primitive types. Integers, you have quite a few of them actually. For this one is i32. The first letter I is either I or U. I means that it's a signed integer, so it can be positive or negative. If you only want positive numbers, you can use unsigned integers, which will be U32. And then after the first letter, you have the size of the integer that you are of the type. So the smallest one is 8, and then it doubles. So 8, 16, 32, 64, and 128. 128 is the largest you have. So this represents the size in bits. So the smallest here are 8, means that it's 1 byte. 1 byte being 8 bits. It's all multiple of 8. So you have 1 byte, 2 bytes, 4 bytes, 8 bytes, and then 16 bytes. The larger the number, the bigger the range. So obviously, if you have U8, you can have a smaller range if you have U16. U8 means that the minimum is an unsigned integer, which has a range of 256 numbers. So it goes from 0 and to 255. If that range is okay for you, that's the smallest. You're going to use only 1 byte to store the value, so that's sometimes preferred. But the common type is 4 bytes. It gives a good compromise between range and storage space. So 4 bytes. That's why the default value is i32. Well, the default literal is i32. So if I don't do anything, this 10 is i32. But if I do 10 u32, then I can see that the type now is u32, and I can do for also like u8. Makes this guy an integer of type u8 of 1 byte. So that's pretty much it for the primitive types. So to recap, we have integer primitive types, I or u, and then followed by a size, which is 8, 16, 32, 64, and 128. Sometimes the machine doesn't have support for such a large data type, 128 bits. You rarely have a computer that has a 128-bit processor, so it's going to be emulated by the compiler. But in any case, you have support in the language. Then you have a Boolean, true or false. Again, it's type for logical statements. Oh, I forgot the floats. Right? So if you are dealing with floating numbers, so decimal numbers, you have two types, F32 and F64. Then after that, we are talking about strings, not strings, characters. Strings are series of characters. So we'll talk about that later. And I think that is it. So the last thing is that the reason why you have types is so that the compiler can check that what you write makes sense. You cannot, for example, add a number to a letter. That wouldn't work. Right? That makes no sense. So the plus here shows an error because you cannot add a char to a U8, and the compiler explicitly tells you why you cannot. Well, that operation wouldn't make sense. You don't know what's the result, and this is checked before you can actually run the program. And in Rust, there are very few. I don't think actually there are any implicit conversions. So if I do, if I have a of type U8, and I try now to do a plus 5, that should work here. Let's see if it works. Yeah, that works. That's the conversion is okay. But if I do a plus 5 0, this guy is a floating number and this one is an integer. So this addition does not work. So this kind of type checking compile time already is a reason why you benefit from using IDE, because you can see this error very quickly. Actually, even before you compile, the IDE has a type checker which kicks in before you actually compile. Right? So I didn't compile, but I can already see that this is forbidden, and I can see that in problems. Float to U8. All right, so that's it for today. Next, we'll see composite types. So types are built on top of these primitive types. See you for now.